In section 4.2, we're going to look at all the different angles of a triangle. A triangle is made up of 3 angles. The triangle sum theorem says the sum of all 3 of these angles will be 180 degrees. The measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 will be 180 degrees. If we take one of the sides of the triangle and we extend it, we create an angle on the outside of the triangle. The angle on the outside of the triangle is called an exterior angle. Now, the exterior angle theorem says that the measure of my exterior angle will be equal to the sum of the 2 remote interior angles. In this case, if angle 4 is my exterior angle, angles 2 and 3 will be my remote interior angles. Now, to get angle 4, we extended this side. If we extend this side of the triangle, we create another exterior angle right here. I'm going to call that angle angle 5. Now, angle 5 is also an exterior angle, so it is equal to the sum of the 2 remote interior angles. If I extend this side of the triangle, I create another exterior angle, angle 6. And the measure of angle 6 is going to be equal to the measures of the 2 remote interior angles. Well, if we look at angle 6, if angle 6 is the exterior, 3 and 1 have to be my remote interior angles. If I extend this side of the triangle, I create another exterior angle. I'm going to call that angle 7, and angle 7 is going to equal the measure of the 2 interior angles. If I extend this side, I create another exterior angle. I'm going to call that angle 8. And the measure of angle 8 is going to equal the sum of the 2 remote interior angles. In this case, angle 1 and angle 2. If I extend this side, I create another exterior angle, angle 9. And angle 9 is going to equal the sum of the 2 remote interior angles. If we look at this triangle, we have other relationships amongst the angles. 1 and 4 and 1 and 5 form a linear pair, as do 2 and 6 and 2 and 7, and 3 and 8 and 3 and 9. And by the linear pair postulate, those angles will be supplementary. And the last set, the measure of angle 3 and the measure of angle 8 are supplementary. And the measure of angle 3 and the measure of angle 9 will be supplementary. We also have some vertical angles. 4 and 5 are vertical, and 7 and 6 are vertical, and 8 and 9 are vertical. And by the vertical angles theorem, those angles will be congruent which means that their measures will be equal. Now there is one angle that we left out. Vertical of angle 1 is this angle right here. We actually don't have a name for this angle. It's not an exterior angle, but it is congruent to angle 1. Same with this angle. We don't have a name for it. We just know that it's congruent to angle 2, and this angle will be congruent to angle 3. Let's use that triangle to figure out some algebra problems. The measure of angle 2 is 85 degrees, and the measure of angle 3 is 40 degrees. And we want to find the measure of angle 4. Well, in order to do that, I want to find a relationship that relates angle 2 and angle 3 and angle 4. So I look at my list. Here's one that relates 2 and 3 and 4. Angle 4 is an exterior angle, so it's going to equal the sum of the two remote interior angles. So that's where I want to start. The measure of angle 4 is going to equal the measure of angle 2 plus the measure of angle 3. Now I'm going to substitute in what I know. I'm trying to figure out the measure of angle 4, so I don't know that measure. And I'm going to substitute in the measure of angle 2 and the measure of angle 3. Doing my math, combining my like terms, these are both degrees, so I can add them together. 85 degrees plus 40 degrees is 125 degrees. In order to solve for angle 1, I want to find a relationship between angle 2 and angle 3 in angle 1. Well, 2, 3, and 1 are all my interior angles, and the triangle sum theorem says that all three angles together will equal 180 degrees. That's where I want to start. The measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 is going to equal 180 degrees. Now let's substitute in what we know. The measure of angle 2 is 85 degrees, and the measure of angle 3 is 40 degrees. Combining my like terms, 85 degrees and 40 degrees gives me 125 degrees. Subtracting 125 from both sides, I get the measure of angle 1 to equal 180 degrees minus 125, 55 degrees. If I look back at my original triangle, I have a way to check my answer. Angle 1 and angle 4 also form a linear pair, which means they have to be supplementary. To check my answer, I can take these two measures and make sure that they are supplementary. 55 plus 125. They do equal 180, so I know that my answer is correct. In my second problem, I'm told that the measure of angle 1 is 30 degrees, which is different than my first problem. So I have a different given, and that the measure of angle 2 is the measure of angle 3 plus 10 degrees. And I need to solve for the measure of angle 2 and the measure of angle 3. Well, I need to find a relationship between angle 1 and angle 2 and angle 3. Angle 1, 2, and 3 are all interior angles, so their sum is going to be 180 degrees. That's where I want to start. The the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 180 degrees. Now let's substitute in what we know. The measure of angle 1 is 30 degrees, so I'm going to substitute that in right here, plus the measure of angle 2. Well, this gets a little tricky. The measure of angle 2 is 3 times the measure of angle 3 plus 10 degrees. So I'm going to substitute this whole thing in right here. So I have 3 times the measure of angle 3 plus 10 degrees. This entire statement is taking the place of the measure of angle 2. And I still have plus the measure of angle 3 equals 180 degrees. So if you look, I really have the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 180 degrees. I've just substituted in what I know. Next step, combine my like terms. On the left side I have 30 degrees and 10 degrees. Well, 30 degrees plus 10 degrees gives me a grand total of 40 degrees. And I also have 3 times the measure of angle 3 plus the measure of angle 3. Well, if I think of a coefficient as nothing more than a tally, this tells me I have 3 measures of angle 3 plus another measure of angle 3. Well, if I already have 3 and I add another one, I have a grand total of 4 measures of angle 3. Think of coefficients as just a tally. They tell me how many things I have. In this case, it's measures of angle 3. Now if this was an x, to solve for x, I would subtract 40 from both sides. That's what I want to do. To get rid of this 4, I have 4 times the measure of angle 3, so I'm going to divide by 4. If I have 4 of them, I'm going to have to divide by 4 to find out what each one equals. (140) divided by 4 equals 35 degrees. So I figured out the measure of angle 3. I need to figure out the measure of angle 2. Well, I know that the measure of angle 2 is 3 times the measure of angle 3 plus 10 degrees. So to figure out the measure of angle 2, I want to use this statement. The measure of angle 2 equals 3 times the measure of angle 3 plus 10 degrees. I'm going to substitute in what I know the measure of angle 3 to equal into this statement, into this equation. 3 times 35 degrees plus 10 degrees. 3 times 35 is 105 plus 10 degrees. So the measure of angle 2 is going to equal 115 degrees. Now to check my answer, all 3 of these angles together have to equal 180 degrees. 30 degrees plus 115 degrees plus 35 degrees. Yep, it equals 180 degrees. I can always check my answers in a problem like this.